This video will help you with some of the more difficult parts of today's lab on locating the epicenter of an earthquake. In front of you now are these three seismograms from San Jose, New York, and San Francisco. We're going to study these three seismograms to determine the difference in arrival times of the P waves and the S waves. We're going to do San Jose, Costa Rica together. So as we go, please fill out the number 1 part of your lab and also the data table in number 2 as we go through San Jose together. So we're going to figure out first what this scale, what this timeline means. You need to understand that this first number represents hours. The second number represents minutes, and the third is seconds. We're only going to be using minutes and seconds today, and so this is how you'll be reporting your data in the data table, not by using the label minutes and seconds. So we're going to look at the numbers here. You see this line represents 20 minutes, 0 seconds. This one represents 25 minutes, 0 seconds. So from your lab sheet in number 1, you have a blown up version of this. You can fill in the numbers with me. If this is 20 and this is 25, then this one is 21 minutes, 0 seconds. This one here is 22 and 0 seconds. This is 23, and this one is 24 and 0 seconds. And that information is going to help us figure out the arrival times as we go. So then we can take a look at this P wave, and it arrives pretty much right on 21 seconds. So in your data table, under San Jose, Costa Rica, first P wave arrival, you can write 21:00 to represent 21 minutes, 0 seconds. Then the S wave arrives over here. We're going to lightly draw a line down to our timeline so that we can figure out how many seconds and minutes this was, what time this arrived. So if this is the 30 line, this is the 31-minute line. If we draw a line in the middle, that would be 30 minutes, 30 seconds. But it's not in the middle. It's a little off to the side. It's probably close to 30 minutes, 15 seconds or so, but our directions told us to round to the nearest 10 seconds. So we're going to mark this as 30 minutes, 10 seconds. 30 minutes, 10 seconds. So that can go in your data table for the arrival of the S wave. Then we need to subtract those. If we have 21 minutes and we need to subtract that from 30 minutes, 10 seconds, we simply subtract and we get 10 seconds here, and 30 minus 21 is 9. So the difference in arrival times between the P waves and S waves is 9 minutes, 10 seconds for the San Jose, Costa Rica seismogram. You can put that in your data table. Sometimes the math is not that easy. Let's pretend the numbers were a little different. What if you had 24 minutes and 40 seconds, and that was your S wave, and if your P wave was 20 minutes, 50 seconds. If we take 20 minutes, 50 seconds away from 24:40, we have a complicated math problem here, subtracting 50 seconds from 40 seconds. So an easier way to do that is to transfer this number into 23 minutes. So I took away a minute, and I took away a minute, which equals 60 seconds. So I'm going to add that 60 seconds here. So I have 100 seconds. 23 minutes, 100 seconds. And now I can subtract 20, 50, and I get 3 minutes, 50 seconds. So if you have a more complicated subtraction problem like this one, where you have a smaller number on top and a larger number on the bottom, just transfer that to an equivalent number, and that will make your life a lot easier. So once you have this information, the S waves and the P waves and the arrival time, now you need to plug that into your book. So in order to transfer that difference in arrival times to kilometers, you're going to use this chart on page 176 of your book. We've already determined that the difference in arrival times for the San Jose, Costa Rica seismogram was 9 minutes and 10 seconds. And so we're going to put that along this axis here. We should first pay attention to how these numbers are delineated, what these lines mean. So if you look at the 7-minute mark here, and then the 8-minute mark, you have two lines in between. And if this represents 60 seconds, then we can determine that the first line represents 7 minutes 20 seconds, the second one 7 minutes 40 seconds, and then you have 8 minutes. Then down at the bottom, here's 1,000 kilometers, here's 2,000 kilometers. There are 4 lines in between. And so this first line represents 1,200 kilometers. This is 1,400, 1,600, 1,800 kilometers to 2,000 kilometers. So each line across this axis represents 200 kilometers. It's an important thing to know as you calculate the distance to the epicenter from the seismogram. So for Costa Rica, our difference in arrival time was 9 minutes and 10 seconds, which takes us off the chart just a little bit. So we're going to bring our fingers across the chart. Now I'm going to write in my book, but you should not, because you're seeing me do this anyway. So if we extend this line, we can assume that the green line would go out to here for about 9 minutes and 10 seconds, just slightly above the 9-minute line. And if we eyeball that down, it would be somewhere around here, which would probably be, here's 7,000, 7,200, 7,400 kilometers. And so that is our distance to the epicenter from the San Jose, Costa Rica seismogram to the earthquake, wherever that happened. It was 7,400 kilometers away. That number should go in your data table, 7,400 kilometers. So now you have completely filled out the San Jose, Costa Rica seismogram data table. You're going to do that same process again for New York and San Francisco. After you have filled out the data table completely, then you are ready. First a piece of cardboard, and then you need this paper. So we need to plot this, and we're going to use this tool. This is a compass, and this tool is a tricky one to use, and they've seen better days, so you need to use them carefully. First you need to put the pencil in. Make sure that the dial, this black dial here, is loose so that you can easily get the pencil in and out. And slide the compass completely together. You want to make sure that the tip of the pencil and the tip of the compass are right on each other, just like so. And then, holding it in place, you can tighten this black dial here so that you have your compass ready to go. Then you can see on the bottom of your map, I have extended your scale for you, but I haven't extended it enough to be 7,400 kilometers. So this is a tricky thing to do. Watch this. And you'll have to do it on your own in a moment, so pay attention. We're going to extend our compass. I have the point on 0, and I'm extending the pencil tip out to 4,000. So that represents 4,000 kilometers. I can move the whole thing, being very careful not to adjust the width of my compass, put the pencil tip on 0, and just put the compass point wherever it ends up. This distance represents 4,000 kilometers. Now I can extend it further. This would be 5,000 kilometers, 6,000 kilometers, 7,000 kilometers, and we need 7,400. So I'm not quite going to go to the 500 line. There's about 7,400 kilometers. Now I need to be very careful not to adjust this width at all as I draw my circle. We're going to take the tip of that compass, put it on San Jose, and holding the top, again being very careful that it does not move, you're going to hold the compass kind of at an angle. Straight up and down doesn't always work so great. Hold it at an angle, and it works best to actually move the paper and to hold your compass still and draw your circle. Now, this is going off the paper, so we obviously do not need to draw the entire circle. This will serve us just fine. You're going to do the same process for the other 2 seismograms, one in New York and one in San Francisco. If you draw your 3 circles and you end up where your circles do not intersect even close, you need to check where you went wrong. Perhaps you went wrong when you were calculating the arrival times into kilometers. Perhaps you went wrong when you were measuring your compass on the scale. Perhaps you accidentally increased the width. Whatever the case may be, it's important that you do redo this lab so that your 3 circles intersect. Maybe it's here near Hawaii or in Greenland or somewhere in Canada. It could be anywhere on this radius here. It's important that both partners do the 3 circles on their own lab sheet, because this activity will help you tremendously when you are explaining how to do it in essay form on the test this week.